Hey guys, so just a quick video going over this last question. I've included over here on the right the formulas, the major ones that we're going to be using for double slit, single slit type things, all right? So the first question says, explain why zero intensity is observed at position A. Now, the problem that most of you had is that you were talking about double slit interference, right? The minimum at A has nothing to do with double slit interference. It has nothing to do with two individual rays of light coming from different slits, because if you look at the double slit interference, right, the double slit interference should have marks that are evenly spaced. There's the first one at the center of the first bright fringe. There's the second one. There's the third one, right? Here's this one. Here's this one, right? It doesn't make any sense to have one here and one there, because then the spacing between these and the spacing between these is different, right? There isn't two bright fringes there. There should be a single bright fringe there, which would make all of these be the same distance apart. Same thing on the other side, right? There should be a bright fringe there in the center of that one. There should be a bright fringe there. There should be a bright fringe there. There should be a bright fringe there, right? All of those marks that I just made are the same distance apart. That's what it should look like if you have double slit interference. Now, the question is, why is there not a bright spot there? Why is there not a bright spot, even though there should be, according to double slit? Well, the answer is because of single slit interference, right? The envelope of single slit is a larger envelope that goes something like this. And it goes up like that and down like that. It comes down on this side. If I were just looking at the single slit, it should look something like this, right? Maybe something like that, sorry. Should hit the tops of those curves, right? And so that blue is what the single slit interference looks like, because that double slit is made up of two single slits, right? So that single slit interference from that slit is coming through in that blue pocket there, right? So coming out of this, you will have a single slit interference, and coming out of this, you'll have single slit interference. And those two single slit interferences are going to come together to create the double slit interference, right? But at this point at A, the single slit should have destructive interference, which means at that specific position, wherever A is, right? If A is right here, then this single slit is showing nothing there, right? This single slit is also showing nothing there. And what happens when you superpose nothing and nothing? You get nothing. So even though they're constructively interfering, which is what the double slit interference says, is that they should constructively interfere at that point, when you constructively interfere nothing and nothing, you still get nothing. So why is zero intensity observed at position A? Well, it's because the double slit interference is composed of two individual single slits. Each one of those single slits is at a minimum at that point, and because they're at a minimum at zero intensity, when I superimpose the zero and the zero, I get nothing. Okay? That's an important idea here so that you'll be able to interpret the rest of the question. All right? Now, the next question is to calculate the width of each slit. Okay, now to calculate the width of the slit is talking about single slit diffraction. We only have one single slit diffraction equation here, that's this one. So we should be going theta equals wavelength over b, right? Now they give us the wavelength, they don't give us the wavelength. What they give us, they do give us the wavelength right up here, the 590. Okay, so we've got that for the wavelength. The other thing, b, is the width of the slit. So that's what I'm solving for here. All right, so now I just need theta. Now remember, theta is from it's the angle from, so if I have my single slit interference here, which looks something like this, right? It's the angle from here, the center bright, to the first minima of the single slit, which is A there. All right? So That's why this is important, okay? That's why this is important right here. So, therefore, with the distance away from the wall and with the distance from that center to A, which is what's given here, you should then be able to calculate the angle. Once you have the angle, that angle will go here. All right? And so you put that angle in, you've got lambda, you should be able to solve for B. Okay? That, of course, depends on the single slit. Okay? The next question is calculate the separation of the two slits. Now, the separation of the two slits now requires there to be two slits, and it's asking from the center of one to the center of the other, how far is that, right? Now, looking at our formulas, that's not this one, okay? Some of you use that one, and we talked about how that one might give you the same answer, but you can't use that one because this is specifically for diffraction gratings. Even if you get the right answer, they will give you 0 credit if you use that. You must use the formula for double slits, which is this one up here, the S equals lambda D over D. And so we go S equals lambda D over D. And you should be able to work through that, right? We're trying to find the separation of the two slits. That would be this guy right here. You have the distance from the wall, which is 7 meters. You have the wavelength. And now we need to find how far apart those individual slits, the bright spots are. So going back up here, I see from here, I go through 1, 2, 3, right? That would be 3 of those S's is where that bright spot should be. It's right in the middle, and it is an estimate, right? We're guessing that it's right in the middle, but that's 3S, and we do have the distance for A. The distance for A was 4.1 times 10 to the negative second. So S will be that 4.1 times 10 to the negative second, but then divided by 3 to get the distance from one bright fringe to the next. All right? So hopefully that will help to answer that question. Make sure that you use the right formulas and the right scenarios, and hopefully that beginning gave you enough information that you'll be able to kind of understand and put together the double slit, single slit ideas. All right?